Shazam, Shazam, Shazam! This is Gomer Pyle here, talking about finding binomial probabilities, section 8.1-2. Alright, let's begin. Okay, the probability distribution function assigns a probability to each value of x, and it's located in this GC, I understand, is graphing calculator under distr. I suppose that's distribution, which is in the second function's vars. If you scroll down to number 0, which is below number 9, you get this right here, binomial PDF, okay, in a parenthesis right there. So locate that on your calculators, boys and girls. All right, and then we'll go ahead and start one of these. So we're going to inspect those switches again. So this is the same problem, but we're going to do a little twist here. So this is example 8.5 on page 442. Okay, Quality Engineer selects an SRS, a simple random sample, of 10 switches from a large shipment for detailed inspection. And unknown to the engineer, 10% of the switches. So there's our probability right there, 0.10. The switches in a shipment fail to meet the specifications. So, and remember, this is what we discussed in that last lesson, what Barney discussed. Was that this was a PDF because 10,000, when you're pulling just one switch away, it doesn't change that probability very much. So what's the probability that no more than one of the 10 switches in the sample fail inspection? Okay, so this is what we're looking for, no more than one. So you can get 0 switches failing or 1 switching failing right there. So write that down, boys and girls. All right, and then so what you're going to do is you're going to use that new feature in your graphing calculator. So go ahead and punch in binomial PDF 10, 0.1, 0. That stands for this guy right here. And then press enter. And then do the same thing for this, 10, 0.1, 1. And then press enter. And you should get these two groovy decimals right there. And it adds up to about almost 74%. So what does that mean? That means about 74% of all the samples of 10 switches will contain no more than one bad switch. Okay? Oh, excuse me. It's always good to be able to interpret what that number means. So I know your fantastic teacher, Mr. Bullock, wants you to be able to interpret that. So don't just leave it like that. Be able to interpret what that means. So 74% of all the samples of 10 switches are going to contain no more than one bad switch. Okay, let's try another one. All right, so here's Kareen's free throw. So this is example 6 on page 443. So Kareen is a basketball player who makes 75%, there's her probability, of her free throws over the course of a season. In a key game, Kareen shoots 12 free throws and makes only 7 of them. Oh my gosh. So the fans think that she's failed because she was nervous. Is this unusual for Kareen to perform this poorly? I hope not, but to answer this question, assume that the free throws are independent with probability of 0.75 of success rate of each shot. Studies of long sequences of free throws have found no evidence that they are dependent of each other, so this is a reasonable assumption to assume that they're independent. So we can do our binomial probability test on this. And so 12 shots, so there's my 12 right there, and each shot has 75, and we want to know, is it unlikely for her to have 7 or fewer shots? Okay, so we're looking for this, you guys, the probability that x is less than or equal to 7. So that would be, the 0 plus the 1 plus the 2 plus the ... all the way up to plus the 7. So you plug that into your calculator and you get all of these right here. Now there's another way. Instead of doing all of them and adding them together, this C right here, boys and girls, stands for cumulative, which means you add them all up. So PDF is just for each probability, but C means you're going to cumulative add them all up. So if you punch in cumulative and get to punch in 12.75 and then 7, this would be 7 or less. So 7, 6, 5, 4, 3, 2, 1, 0. All right? And you're going to get the same answer. All right? Remember, Mr. Bullock likes you to interpret that answer. So Kareen's going to make at most 7 of her 12 free throw shots in about 16% of the time, or roughly in 1 of every 6 games. So that's below her average, but this performance is well within the range of the usual chance of variation. So we're going to be looking for later, I understand, from your fantastic teacher that if it's below 5%, then that would be something to be worried about. But if it's not below 5%, I think we're safe. Okay? All right, let's try another one. This is fun. All right, so 3 girls. Okay, now this is example 8.7 on page 443 and 44. Okay, 3 girls. So in activity 8, and I understand you did not do activity 8, but in activity 8, we wanted to determine the probability that all 3 children in a family are girls. Okay, so they had 3 kids, and what's the probability that they're all 3 girls? So in this case, the random variable of interest is x equals the number of girls. And so we're going to, so we want to know what's the binomial distribution of 3 and then 0.5, because it's 0.5 boys, 0.5 girls, 50-50. So we want to find the probability that the number of girls is 3. That is x equals 3. Okay, this one is a PDF, you guys, because we don't want 3 or less. We want exactly 3. So you're going to punch in PDF of 3.5, 3, and you're going to get roughly 12.5% of the time it's going to be all 3 girls. Okay? Alright, so here's the assignment I'm supposed to give you along with that other one, the 8.1 and 8.2, and then go ahead and add to this 8.3 through 8.7 all.